So in this video, we will be talking about putting everything together to solve limits algebraically. And to do that, we are going to need all our properties here. And I'm going to first use all the properties and show you how to get limits. And then I'm going to show you an easier way what the overall outcome is from all these properties. So to start, let's take a limit. So the first thing we want to do, or notice here, is that we can distribute. So using property 2, the difference rule, that we can distribute the limit. And so that's something we can do. And so there we go. All we did was use property 3 or property 2 here to distribute the limit. And so now what are we going to do? Well, let's look at this first limit here. X squared is a polynomial. And so we can use property 8 then. The limit of a polynomial is always equal to simply plugging in our c value into x. So that means this limit here is just plugging in minus 3. So that limit, we just plug in minus 3. That's property 8. The limit of all polynomials is just simply straight function notation. Just plug that c in. Now, what about the limit of a constant? So a challenge, I think, coming from algebra to calculus is I think most students are in a mind frame when they see a number that you think of a quantity. Like when you see this 13 here, who knows what you're thinking? 13 pillows, 13 cars. I think people normally associate number with some quantity. But in calculus, you really want to start thinking of these numbers as functions. And a number is a constant function. It's just a horizontal line. The output never changes. And the limit of a constant is always that constant because it never changes. So it doesn't matter what x goes to. There's no x in a constant function because it doesn't change. And so the limit of something that doesn't change is just that thing that's not changing. So the limit of a constant is always that constant. And so there are the numbers we have. And of course, then the last step here would just be to do the arithmetic here and get our answer. And that's our answer. The limit is minus 4. And again, we got this entirely from using the limit properties. So let's check out another one. Now, first of all, if we look at property 3, a constant we can pull outside of the limit. So here's a constant, and we can pull that outside the limit. And now let's look at what we have. We have 2 factors. Now, yes, you could distribute this. Nothing wrong with that. But I do want to use property 4 here to demonstrate this. If we have factors, then we can pass the limit along to each factor. And so there we go. the product rule number 4. We're passing the limit to each factor. So the limit, if we look at the limit, it's now connected to a polynomial. X minus 5 is a polynomial. And so we go to property 8. The limit of a polynomial is always just this function notation. Just plug the number in. So to find this limit here, we just plug in the number 6. And same with this next limit. It's a limit of a polynomial. And so we just plug the number in. Again, that's a property of polynomials. And then finally, we'll just figure out what this number is. And that's our answer. Check out another one. So here we have a quotient. And what can we do with a quotient? Well, we would go to property 5, the quotient rule. And that says that we can pass the limit along to the numerator and the denominator. So we can take the limit and pass it along to the numerator and the denominator. And that's property 5. And now notice the limit is connected to polynomials. And so we can use property 8. And so we'll just plug the number in. So because this is a polynomial, we can just plug the 2 in there. And the same with the bottom. Because this is a polynomial, we can just plug that 2 in. And now all we have to do is figure out what that number is. And I suppose we can still reduce that to get our final answer. So let's check out another one. Square root. Now, very important going forward into calculus that you understand that the square root means raised to a power of a half. So the square root symbol means raised to a power of a half. Now, 1 over 2 falls into property 7, since 2 is a positive integer. And property 7 says then we can bring the limit inside the exponent. So we can stick it right here in the parentheses. And that was property 7. And now notice the limit is connected now directly to a polynomial, which means then we can use property 8. And property 8 says if you're taking the limit of a polynomial, just plug that number in. And now that it's just numbers, we'll just do that arithmetic and figure out what that answer is. So we would have 16 minus 10 here, which is 6. And then we're ultimately taking then the square root of 6. And that's our answer. Now, all of these properties here, I try to be rigorous here in going through the properties. But if you notice, I'm just going to scroll all the way back to the starting again. Look at our first problem here, x squared minus 13. And we got an answer of minus 4. Notice if we just plug in minus 3, we're just going to plug in minus 3. We will get then 9 minus 13, which gives us our minus 4. In other words, this entire first limit here, we could have obtained just by plugging the number in. And same with this next one. So we started here with the first line right here. If we notice our last line right here, the last line is just, all we did was plug in the 6. We plugged a 6 in here, we plugged a 6 in here, there it is, and we got our answer. So all of these properties result in just plug the number in. Let's check that out for this next one. Here's where we started. We went through the limit properties, and we came to this expression right here. And notice this expression is just plugging in 2. We just take 2 and plug it into the x's. We get our final expression here that gave us the answer. So all these rules lead to a simple pattern. You just plug the number in. And again, that same thing is true with this problem. We just plug 4 in, we'll have 16 minus 10, which is square root of 6. We just plug the number in. Now, it is true that for the vast majority of your homework, you can just plug the number in. Now, there are some cases where this will fail, and this will always fail at a gap. And as I talked about last time about properties, I tried to point out the gap. It's a good thing to be able to identify. And this simple result of just plugging in the number will always work unless there's a gap. So let's try using this idea of just plugging the number in. And before we get to that, though, I have to talk about something that's probably new, and it's called the indeterminate form. The indeterminate form is what we call 0 over 0. And that may seem a little bit bizarre. 0 over 0. Isn't division by 0 undefined? So let's take a look at that real quick. Let's say a is some number here. I'll say 2. Let's say 2 divided by 0 equals something. We don't know. We'll just call it b. Now, if we multiply both sides by 0, so if we multiply both sides by 0, we will get this expression. Now, if you look at this, 2 equals b times 0. Well, what number b solves this? And the answer is, well, there isn't. There is no number times 0 that will get you 2. So this equation has no solution, which is then the result of why we say division by 0 is undefined. Because there's no solution. There's no answer for what b can be here. Anything times 0 will be 0. So there's no solution here. However, what if instead of 2, this was 0. So let's say 0 divided by 0 equals something. We don't know what that something is. We're just calling it b. And let's rearrange that again by multiplying both sides by 0. So I'm just going to multiply both sides by 0. And now look at this expression. b times 0 equals 0. Well, that's true. B can now be anything. Anything times 0 is 0. And this is the indeterminate form. The indeterminate form, 0 divided by 0, means the answer could be anything. And then your goal is to get rid of 0 divided by 0. In other words, there are manipulations you can do to get something out of the indeterminate form. And that's what we're going to be doing now. All the problems going forward in the last part of this homework, they will all be indeterminate forms. And it will then be your job to figure out how to get out of this indeterminate form so that you can get an answer. And again, it's called indeterminate because we cannot determine the answer. We have to do something else to get to the answer. So let's check out a problem with an indeterminate form. So I just got done saying that the easy way to do limits, and again, you have to be careful here that you're not at a gap, but the easy way to do a limit is to simply plug the number in. So our number here is 5, and so we'll simply plug it in. And now notice what this equals. This equals 0 over 0. So this limit is in the indeterminate form. We cannot determine an answer as it's currently written. And so we have to do something else to try to get out of this. And what is that something else? Well, x squared minus 25 is the difference in squares. And so hopefully you remember some things about difference in squares. That we can factor that. And now notice that we factored it. The x minus 5s will cancel. Now, did this do anything? I don't know. The only way you're going to know is to check again. So let's check. Let's see if that did anything. Let's plug 5 back in. Well, if we plug 5 back in, we now have an answer. 1 over 10. And that is our answer. The limit is 1/10. So let's check out another one. Now the easy thing to do is to simply plug the number in and see what happens. So we're going to plug in minus 3 and see what happens. And we'll figure out what this number is. So the numerator, minus 3 plus 3 is 0. We look at the denominator, we have 9 minus 12, which is a minus 3. And then minus 3 plus 3 is 0. So this limit is in the indeterminate form. And we have to do something to get out of it. Well, you look at the bottom here, you have a quadratic, and factor it. Now, do you know if this is going to lead to an answer? No, you don't. But you should try whatever you can. So if you look at the bottom here, you're like, oh, I know how to factor that. I don't know if that's going to lead me to an answer, but it's something I can do. And I encourage you just to do things. Don't be concerned if it's going to get you to the answer. Just try things and see where it goes. So let's just try this. We're just going to factor this out. So we have 1 times 3 here will get us a 4. So we'd have 1 and a 3. So all we did was factor that denominator. And now we can see that these x plus 3's cancel. So that seems pretty good. And once we do something, let's try the number again, because maybe what we did worked, or maybe it didn't, and we'd have to do more. So we're just going to plug the minus 3 in and observe what happens. Oops. And we get an answer. And that is our answer. This limit is equal to minus 1/2. Let's try another one. So again, if we plug 1 into this, we'll find it's in the indeterminate state. And so we need to do something to get out of the indeterminate state. And we have 2 quadratics here, which we can factor. So let's just do that. So on this top part here, we got a minus 2 and a positive 1 there. Oops, can't quite hit that plus sign. And on the bottom, another difference in squares, x squared minus 1. And there we go. So all we did was factor these quadratics. And we can see now an x minus 1 will cancel. And now that something has happened, let's try the number again. So we're just going to take 1 and plug it in. And there's our answer. This limit equals 3/2. So we'll try another one. This one definitely looks more complicated. And if you plug in 0, you'll find this is 0 over 0. So this is in the indeterminate state, and we need to get out of it. So what can we do in this case to get out of it? Because there's nothing to factor here. So factoring is not going to get us anywhere anymore. And what we can do, though, is we can add together these terms in the numerator. Now, do we know if that leads to the answer? We don't. But I'm encouraging you to try whatever you see, just give it a whirl and see if it'll get you somewhere. Don't spend a lot of time banging your head against the wall thinking, will this work, will it won't? Just try some things. And most of the time, just doing what you can will get you to an answer. So what am I doing here? Well, I'm going to add these together with a common denominator. So the common denominator is going to be x minus 1 times x plus 1. So I have to multiply this by x plus 1. And then we have to multiply this term by x minus 1. And there we go. I added the terms together. A little messy, so we'll clean it up. In the numerator here, we see we have 1 minus 1, so that subtracts out. And x plus x is 2x. So cleaned it up a little bit. Now we do have a complex fraction here. And if you recall, division is exactly the same as multiplying by the reciprocal. So this division by x, instead of division by x, I'm going to multiply by the reciprocal. And now, hopefully, it's a little bit clearer to see that these x's will cancel. So these x's will cancel. And that's just 1 over 1, which is just 1. So we had something cancel. Maybe that did something. Let's check it out. And to check it out means we're going to plug the number in and see if we are no longer in the indeterminate state. So let's plug in 0 for the x's and see if we get a number. So we'll have 2 over minus 1 times 1. And that's our answer. This limit up here equals minus 2. Let's try another one. And this one's probably going to be a little bit more scarier for some people because of the square root. Now again, if you plug in 9, square root of 9 is 3. So we have 3 minus 3 is 0, and 9 minus 9 is 0. This is in the indeterminate form. And so we have to do something to get out of it. And what can we do with a square root? Well, when you have an equation, we don't have an equation here, but when you do have an equation, one way to get rid of a square root is to square both sides. That's pretty common. But how do you get rid of a square root when you don't have an equation? And the answer to that is the conjugate. Now, if that's new to you, the conjugate simply means switching the sign between the terms. So the conjugate of square root of x minus 3, the conjugate here is just switching the sign. Now, we have to multiply by 1 so that we don't change the value of the function here, which means then we have to do the conjugate over the conjugate so that this whole thing equals 1, because anything divided by itself is 1. And so this doesn't change the value of the function then. And so that's what we're going to do here, is we're going to multiply by the conjugate. And I just want to quickly say that if you ever see a square root in your homework problem, you should automatically think conjugate. For your homework problems, the only way you're going to get out of a square root is the conjugate. So we do need to multiply these together now, and I'm just going to put some parentheses around here real quick so you can think of distribution or FOIL or something. So let's look at that numerator. Square root of x times square root of x is x. So I'm just doing square root of x times square root of x. Now we're going to have square root of x times 3. So that would be plus 3 square root of x. And then we'll do minus 3 times square root of x. And of course, those will subtract out. And then finally, minus 3 times positive 3 to get us then a minus 9. And for the denominator here, I know you're going to be tempted probably to distribute that out, but it's actually a little bit easier in this case to not distribute it out because we want things to cancel. And in order for things to cancel, we need to have some factors. So I'm not going to distribute the bottom there. And now we'll work on trying to clean this up. So first off, these 3 square root of x's will subtract out. And this is why I didn't distribute, because now this x minus 9 will cancel this x minus 9. And that's why you don't want to distribute here. So something happened. We got a cancellation. Now, did this help? Well, let's check it out. And how do we check it out? By plugging the number in. So we're just going to take 9 and plug it in for x. And the square root of 9 is 3, and 3 plus 3 is 6, and that's our answer. This limit equals 1/6. So I want to stress again, if you ever see a square root in your homework, go immediately to the conjugate. The conjugate is how you will deal with the square root. And since I know the conjugate may be new to some people, I do want to do another one. And this time I'm going to put the square root in the denominator here just to mix things up a little bit. So there's a square root, which means we're going to use the conjugate. And the conjugate means just switching the sign between the terms. So instead of that being a -2, we're going to make it a +2. And to make sure we don't change the value of the function, we're going to have to multiply this by 1. So anything divided by itself is 1. So the whole thing in blue here is 1, which won't affect the function output. So we're multiplying by the conjugate. And now, in this case, we want to distribute the denominator. So the square root's in the denominator this time, And now this is where we will distribute it. So let's take a look at that. Let me just put some quick parentheses around here again so you can clearly see that we're going to do some distribution here, the FOIL method. So we have square root of x plus 3 times the square root of x plus 3, which is x plus 3. And now we're going to have the square root times 2, but we're also going to have the square root times minus 2. And those will always subtract out. And this is the usefulness of the conjugate, is that these middle terms will always subtract out. And so all that's left is minus 2 times positive 2, which is minus 4. And in the numerator, we are not going to distribute because we want things to cancel through division. And so we need factors in the numerator to do that. And, ooh, that's looking a little bit messy there. Let me just make that a little bit cleaner looking. So there we go. Here's our conjugate. And here's the result of distributing that out. And real quick here, 3 minus 4 is minus 1. And now notice the x minus 1s cancel. And again, that's precisely the reason why we don't want to distribute, so that we can get that cancellation to occur. So these x minus 1s will cancel. And of course, division by 1 is redundant to right there, so I'll just get rid of it all. So here's where we're at now. Did this do anything? Well, the only way we're going to know is by checking. So let's plug the number 1 in to see if we're out of the indeterminate state. So we'll plug 1 in. So 1 plus 3 is 4. Square root of 4 is 2. 2 plus 2 is 4. And that's our answer. This limit equals 4. So this is obviously very different from graphing and the tables we did previously. Now we're using properties of the limit and just simply using the properties to get to an answer. And notice that all of these problems were two-sided limits. So never did I ever have a plus or minus on our approaching number. These were all two-sided limits. So we are a trig-based class, unlike, say, Math 213. 221 does involve trigonometry. And there are some trig problems in this homework. But before we get to those trig problems, and the reason I have to talk a little bit more is because trig problems, trigonometric functions no longer satisfy property 8. Because property 8 is for polynomials. And trig functions are not polynomials. So how can we get answers then if we don't have this property 8? Because notice property 8 is actually what gets us all our answers for all the problems we did. So to talk about that, I want to talk real quick about how we know if a limit exists. So imagine that you have 2 points. Now these 2 points we can connect with any line that we want. And I'm just going to make up some line. We can connect these 2 points with any line we want. And I'm going to put people at the end of these lines. My people look like blue boxes. But imagine we have a person here and a person here. Now, because this is a solid line, means that these people can walk wherever they want on this line. There's nothing that stops them. There's no hole, there's no barrier in their way, there's no gap. It's a solid line, and so these people can meet wherever they want on this line. So let's say I want them to meet at this red line. Well, the left person can walk here, and the right person can walk to here, and they will meet. This is all because they are connected by a solid line. Now, these people are meant to be an analogy to the left limit and the right-sided limit. So this person on the left would represent coming from the left, and this person on the right represents coming from the right. So if there's a solid line, then that solid line will have a limit everywhere, because you can always approach from the left and the right, and because it's a solid line, means they will always meet. Let's say, though, I stuck a hole in here. Now, with a hole here, this person on the right can't pass a hole. The line is now broken. And so there's no way for this person to get here. Our person can't jump. They can't get past this hole. And I want to be clear here that what I've really done with this hole is I've now broken this into two lines. I now have this solid line, and I now have this solid line. And so if I want my people to meet at this red point again, my people have to be on the same line. So I need to take my person and move them over here. And now these people can meet again anywhere on the line. So a hole is breaking a line into two lines. And so why is this useful? Well, because with trig functions, we are going to look at what parts are a solid line and then what parts are disconnected. So let me throw a problem up here real quick, and I'll give you another picture. Let's say we need to figure out this limit with this trig function here. And let me use some limit properties. So we know the limit distributes. So I can take the limit and distribute it to each of these terms. And let me do one more quick thing. Another limit property says if you have a constant, you can pull it outside the limit. And just because that looks a little bit messy there, I'll just put parentheses there. And what is the limit of a constant? You should burn this one into your brain. A limit of a constant is always that constant. So the only thing we need to figure out here is what is the limit of sine as x goes to 0. So let's take a look at the sine function. And you can see the sine function is one solid line. And because the sine function is one solid line, means the limit exists everywhere. Because no matter what point I pick, my two people can always come from the left and the right and meet at exactly the same place. So sine everywhere has a limit. So if we look at an input of 0, well, if we approach 0, what height are we at? We're at 0. So the limit of sine as we approach 0 is 0. So the limit of sine right here is 0. And that gives us our final answer then, -1. And that's the answer to this limit. Now notice again, we can get this answer, -1, by simply plugging in x equals 0. And this just plugging in a number, this always works if you have a solid line. And that's kind of that is the caveat here. So plugging in a number, wow, that's nice and easy. I'm going to do that. And most of the time you can. But you have to make sure that if you're just going to plug in a number, that you're dealing with a constant line, a solid line. And I'll demonstrate that in the next example here. So let's try another trigonometric function. Secant. And what does secant look like? Well, here's what it looks like. Secant is not one solid line. Secant is an infinite amount of solid lines. And these are all kind of parabolic shaped. And a secant has vertical asymptotes, infinitely many of them, all between these shapes. So what does this tell us about the limit? This tells us if we are on a solid line, then the limit exists. If we are not on a solid line, like at the vertical asymptotes, then the limit does not exist. So the question you need to answer then is, x equals 0. Is x equals 0 on a solid line, or is it not? And if we look at x equals 0, we'll see it's right here, and it is on a solid line, which means its limit will exist. So if you approach 0 from the left and the right, you'll end up right here at a height of 1. And that's the limit. Let's try another one. Just try to go through a couple trig functions here. I wanted to do secant because I know that's not a little bit scary of a trig function there. But let's try something that looks a little bit more complicated. And so our first thing we can do is we have a polynomial here. And we know for polynomials we can just plug the number in. Now what about cosine though? Now cosine looks just like sine, except it's shifted. In other words, cosine is also a solid line. And this is sine. I just quickly here added in a cosine function. Here is cosine, what cosine looks like. It's a solid line, which means the limit exists everywhere. Now we're interested in x equals 0. And because it's a solid line everywhere, means that we can just plug the number in. So a polynomial, we can just plug the number into. Cosine is everywhere a solid line, and so we can just plug our number into that. And so what do we have from there? That was me dinging there. So we have 0 minus 1. And then we have 2 minus cosine of 0. Cosine of 0 is right here. And cosine of 0 is 1. And that is our answer for this limit, minus 1. And I do have another graph here that I threw on here, the tangent function. So here's what tangent looks like when you graph it. And tangent is also split into infinitely many lines. So there's a vertical asymptote that separates all these lines. So for tangent, if you are on a solid line, the limit will exist. If you're not on a solid line, in this case for tangent, that means you'd have to be at a vertical asymptote then the limit does not exist. So for your tangent functions, this is what you should look at and determine if you are on a solid line. And if you are, then you can just plug the number in to get that limit. So there we go, doing limits algebraically. And I want to reiterate real quick here, what we went through is that the simple thing to do is to simply plug the number in. If you plug your number in and get a number out, that's your answer. Now, sometimes when you plug your number in, you will get 0 over 0. And that's the indeterminate state. And then you have to do more. And what were the things we did in the indeterminate state? We factored. So remember, indeterminate state, what can you do? We factored. Another thing we did is we combined terms with a common denominator. And let me see maybe if I can just scroll up here real fast to some of that. So here we are. So like this first problem we did here. So here's where I talked about the indeterminate form. And the first problem we did here, that was factoring. Factoring led us to our solution. The second problem we did also required factoring that quadratic, and that led us to a solution. The third one we also got by factoring. That led us to our solution. Now this fourth one, this is where we combined terms. We added these two terms together in the numerator. We combined the terms, and that led us to our answer. And then the final strategy was the conjugate. And the conjugate, I know may be new, but is probably the easiest to use because whenever you see a square root, you should use it. So the square root, if you see a square root, that's your big flag. Oh, I'm going to use conjugate here. And again, I did another problem with the conjugate. So try to remember that going forward. What did we do to solve these? Factoring, combining terms, conjugate. And that is the material that will help you finish then the next homework.